Hello dear students and viewers, today I am showing you how to plot a closed traverse. So this is the calculation which I had already explained in the earlier video. So today I am showing you how to plot this data. Okay, so we will use only this forward bearing, that means from corrected bearing, so corrected forward bearing, and the reduced length, this one. Okay, so how we got this value, this is already explained. So all from this value we actually reduced the length here. So here one thing very important, that is, if we select this scale, suppose 1 cm to 10 meter, then it will be double. Suppose if you select a scale 1 cm to 5 meter, then it will be 1 cm to 10. If you select 1, then it will be 2. Okay, so in this way we will get all these values, and finally sum of all these values. So here the total value is 10.45 centimeter. Okay, so now I am showing you how to plot. So we will use only this forward bearing and this length. Okay, so here the first forward bearing is 13 degree. So I will start the plot from here. Okay, so this is my starting point. So I am using a protractor, you can see. So place the protractor here, this is the midpoint, in this way. Okay, so you can see my protractor is placed, and the first forward bearing is 13 degrees. So this is 10, 11, 12, 13. Okay, I am just marking it, then this is actually 13 degree. Okay, so this is 13 degree, that means in this direction. So now we will use the length. So the first length, that means if this is our M station, you can see here this is M station, right? So the length of M station is actually 4.5. so the first line, that means MN line, the length of this line is actually 4.5 centimeter, right? So in this way we will take a length of 4.5 centimeter. So you can see here I am place the scale on this direction. So don't place it in this way or in this way. Okay, just on the point. So this is the point, and the length is actually 4.5 centimeter, right? Four 4.5 centimeter. Okay, so from here to here it is actually 4.5 centimeter. The length of this line is 4.5 centimeter, and the direction is 13 degree. Okay, so now you have to draw another plus, that means plus symbol here in this point, in this way. Okay, so this is the second station. So this is our first station, and the name of this station is actually M. I'm writing here M. This is actually our second station. The name of second station is N. So this is the north line, north direction. This line indicates the north direction. Next value is the first is 13, then is 58. So I'm placing the protector here. You can see that the second value is 58. You can see clearly this is the midpoint, okay, and this is 50 degree. Don't take the below reading because here it is 0, so next reading is 350. Not, this is actually not 350 degree. You have to take the reading this one, okay. So this is actually 0, then 10, 20, in this way. This is actually 50 degree. So here actual reading is 58, right? So 55, 6, 7, 8, here this is actually 58. So this is the direction, but the length of this line is actually 4 centimeter. You can see here 4 centimeter, okay. So I am drawing the next line. You can see here I have drawn line of 4 centimeter, okay. So here it is 4 centimeter. Again we will draw the plus symbol. So I have drawn another plus symbol, and you should keep in your mind that this line, this knot line, is parallel to this knot line, okay. This is very significant. That means this line and this line is parallel to each other. Not only this one, all the knot line should be parallel to each other, okay. So this is another knot line, and I am taking the next line. Okay, the next value is 135. So the next value is 135 degree, right? So this is 100, 110, 120, 30 and 35. Here it is actually 135. So this is the 135, and the length is you can see here the length of this line is actually 4.3. You can see here 4.3, okay. So now I am drawing a line of length of 4.3 centimeter. So this is 4.3. So this is 4, 1, 2. This is 4.3 centimeter, okay. Next, again draw a plus symbol. So how to draw, I am showing here. You can see. So when you will draw the knot line, use the first knot line, because if you use this knot line, the distortion will minimize, okay. So I am using this knot line using set square, like this way. I am drawing here another knot line on this point. So this is, you can see here it is parallel, this knot line and this one is parallel, okay. Again this one is parallel, so all knot lines should be parallel to each other. This is very significant. So this is another knot line. So this is actually M, then N, it is actually O, and this is actually P, okay. This is north side. Next reading is 219 degree, okay. So 219 degree mean, so here it is 219 degree. So 210 to 20, 219 degree, okay. Here the central point, and the 0 should be kept in the upward side. That means towards northern direction, north direction, okay. So 0 should always kept in upward side. So this is actually 219 degree. After that, the length of this line, that means PQ line. So length of PQ line is actually 4.2. So I am using 4.2 here. This is 4.2. I got another line. Again you have to draw another north line, okay, and I'm using the first north line. So draw here another north line, okay. I'm drawing here, I'm drawing here, okay. So this is another north line, and this line indicates the northern direction. So MNOP, and this is actually our Q station. And finally the last station. So as it is a closed traverse, so the beginning point and ending point actually should be coincide to each other, but sometimes what happens, they fails to meet each other. So what happens in this case, the last reading is actually, the last forward bearing is 294, so we will use 294. So 294 means this is 290, okay, and 294 means here this is the direction, and the length is 3.9 centimeter, okay. So 3.9 centimeter in this direction. So 1 2 3, 3.9 mean here, okay. So this line actually fails to meet with the beginning point. Actually this is the ending point and this is the beginning point, okay. So as it is a closed traverse, so normally what happens, the beginning point actually meet with the ending point and it will form a closed traverse, but it is now it is looks like a open traverse. So actually if there were some mistakes or error, then this actually happen, okay. So I am giving this name of the last point is suppose uh, small m, okay, small m. So this is the last or ending point, this is actually small m. Now what we will do, actually this is the ending and this is the beginning point, so we will join these two point and we will create a closed traverse, okay. So now this is a closed traverse. So this is known as actually closing error. So basically closing error is, so the closing error is the distance, that means this distance, okay, by which the traverse actually fails to close to each other, that means this distance is known as the closing error. So there are few methods by which we can actually correct this closing error. So the most popular method is actually Bowditch rule. So using Bowditch rule we can correct this closing error. So Bowditch rule is actually uh, a graphical way. So how to use this graphical way, now I'm showing you. So here the total length, that means sum of these values is actually 10.45. so now draw a line of 10.45 here. I'm showing you how to draw this line, okay, 10.45. so 10.45, 10.45 mean here you can see. So I have drawn this line of 10.45 centimeter. Okay, and now I will take all this value. So the first value is 2.25, so I'm cutting here 2.25, 2.125, so this is 2.25, this one. Okay, then 2.0, so 2.0 and 2.25 mean 4.25 here. Okay, then 2.15 mean 6.40, 6.40 here, and last one is 2.10. So the first value is 2.25, then 2.0, then 2.15, then 2.10, then last one is 1.95. Okay, so in this way you have to divide the values. Okay, so using a divider, take this distance, that means m to m, that means capital M to small m. Okay, so this is our actually closing error. So vertically cut this line here, this is actually our closing error. So if we write the name of this point, so this will be the M, then N, O, P, Q, and this is actually small m, and small m again meet with the capital M. So this is actually our closing error. This one is actually closing error. Okay, so the Bowditch rules actually shows that if the error between m and small m is this one, then what will be the error in Q, P, O, N? So we will draw a triangle and then cut the line vertically. Okay, all the lines vertically. Here I am showing you. This is very significant that the line should be vertical. Okay, all lines should be vertical. These lines should be vertical. This is very significant. Okay, so now we got the different error of different stations. For example, this one for N, and this one for O, this one for P, and this one for Q. Okay, so N, O, P and Q. Now we will draw some corrections lines for each station, like for N station, for O station, for P station, and for Q stations. So here one thing is very important, that all these correction line, the direction of this line is actually, this is actually wrong point, so wrong to right, so this will be the direction. That means this is the direction. That's why this point is actually wrong. That means some error is happened. So the actual point is situated in this way. Okay, so in this way, so the direction of this correction line is always last point to first point. So this is the beginning point and this is the ending point. So ending point to beginning point, this is very important, and always follow this rule. That means last point to first point or ending point to beginning point. So in this way, so suppose if the last point is here and the first point is here, so the direction will be in this way, right? So if the direction is this way, then all correction line will follow the same thing. That means in this way, this way, this way. Okay, now we will cut each correction distance, for example for Q, this one. Okay, and this is for Q. Here you can see this is for P, this is for P, this is for O, here it is O, and this is for N, very small, this is for N. Okay, and next join all these points. So this is for N, then O, this is for P, and this one for Q. So the starting point is okay, so I am drawing this line. Okay, then this one, then this one. These are actually corrected lines. And the last point is M. So now I am joining this line with M. So this is the M line. Okay, that means this is N and this is small n. Okay, this is O, this is small o, and this is P. This one is actually small p or corrected point. This one is small q. So all points have been drawn, and this is the actually final drawing of this closed traverse. And now some formalities are there, that means leveling are there, like you have to write some basic thing like scale. You can draw a scale also here, a linear scale. We have actually selected 1 cm to 10 meter. So I am drawing here a line. So this is actually 2 centimeter. So each centimeter represents 10 meter, right? So this is 0, this is 10, this is 10, and this one is 20 meter. You can also write the statement scale here, 1 cm to 10 meter, or you can also write the RF here. Okay, so the RF will be 1 cm to 10 meter. That means 1 is to 10 0 because meter and centimeter relation is 100, so double zero, that means 1000. Okay, and this is actually closing error. Okay, and some other leveling thing, like we have actually used different kind of lines. So make a box for different lines, like the straight lines, the big or spacious dash line and the small dash line. Okay, so this is actually observed line, OB, observed line. So observed line mean actually MN, you can write here also MNOP Q, capital Q and M. These are the observed line. Now the corrected line. The corrected line start from M. Corrected line. So it is started from M, then small n, small o, small p and small q, and finally again capital N. Okay, so these are the corrected lines, and finally closing error. So closing error mean the first closing error is this one. So this is actually M dash small m, N dash small n, O dash small o, P dash small p, and Q dash small q. Okay, so right here index and close the box. Okay, now another thing, you have to draw a knot line. So as I am always follow this knot line, so I will draw the knot line parallel to this station. So I'm drawing here a knot line. This is the knot line. There are so many symbols for knot line, you can use any of them. I am using this simple way. So this is the knot line, and this is actually our adjusted scale, that means correction scale. So we use this correction scale, that means 1 cm to 20 meters. So right here 1 cm to 20 meter. Okay, and also right here that adjustment, so I have written here adjustment of closing error by Bowditch rule. Okay, and the next thing is heading. So right here, this is actually parallel median method I have written here. Okay, so now the plotting is finished. So thank you for watching. So this is the final work. You can take a screenshot of this one. Thank you.